Hey, chemistry class. I received a question regarding our acid-base titration lab, and the question is number 7, which says, you now know the volume of the diluted vinegar, the molarity of the base, and the volume of the titrant. Calculate the molarity of the acetic acid in the diluted vinegar. And so the equation that they're asking you to use on the first page of your lab write-up in the sample problems is this equation right here. The molarity of the acid times the volume of the acid is equal to the molarity of the base times the volume of the base. Now, if you understand the units that are involved here, molarity is moles per liter. Volume, if it is measured in liters, basically what you have here is this is going to be the number of moles of acid, and this is going to be the number of moles of base. And in this particular reaction, the acetic acid and the sodium hydroxide react at a 1-to-1 ratio. So that's why this works in this situation. We can use this relationship, and as long as we have 3 pieces of information, we can use this to calculate the fourth. So what we had in our lab is, of course, we started with exactly 1.0 milliliters of acid. Remember, we got that out with a pipette and counted drops to get exactly 1.0 milliliters. Now, the molarity of the base was given to us on the titrant bottle, the dropper bottle, and that was 0.1 molar sodium hydroxide. And the volume of the base, of course, is what you were testing to find out. And so I don't have that piece of information in front of me, so I'm just going to just use a volume as an example. This won't be the exact volume, most likely, that you calculated in your lab, but just for the purpose of running through the calculation, we're going to use 1.7 milliliters of sodium hydroxide solution. And then we're just going to plug into this equation, and we're going to calculate it out. So molarity of acid times the volume of the acid, which is 1.0 milliliters, is equal to the molarity of the base, which again is 0.1 molar, times the volume of the base, which is, we said, 1.7 milliliters. Okay, so then when we divide out this 1.0 milliliters to get all of this to cancel on this side, okay, we're going to do the same thing to the other side of the equation. We're going to divide by 1.0 milliliters. Of course, our units cancel, right? And when we calculate that out, we find that the molarity of the acid is equal to 0.17 molar acetic acid solution. Now, we need to look at significant figures, okay? The precision of the molarity measurement on the dropper bottle was 0.1 molar, and so there's only one significant figure. So when we take that into consideration, then the molarity of the acid that we're left with is 0.2 molar acetic acid. And then you're going to use that in the further calculations that you have in the rest of your lab. So I hope that helps.